Hello, welcome to another Arduino example. In this example, we'll be implementing a mini energy management system. So over here, what we have is a custom-made 24-volt battery pack, 3D printed and made in-house. And on this side, we have a 24-volt DC motor and a motor driver with the speed control and a switch to turn on, turn off power to the motor. And the DC power supply in this case is acting as a charging station. So when I turn on the power supply, it's going to charge back the battery pack. When I turn on the DC motor, it will discharge the battery pack. And in any case, we'll be using the fan on this motor to cool down the cells if we're charging or discharging. And green LED will indicate discharging, whereas red LED will indicate um, green LED will indicate charging, and red LED will indicate discharging. So without further ado, let's get into it. So I'm going to make this. So let's go over the code. So we have two analog inputs in this case, the voltage sensing and the current sensing, and then three digital outputs, the fan, and the two LEDs. So these are the parameters needed to convert the analog signal into current and voltage readings. So the Arduino can read only up to 5 volts. So there is in the sensor, there is voltage divider circuit. So this takes the analog input and then converts the higher voltage that the battery pack is at into a lower voltage on the voltage divider circuit, and then converts it back into the higher voltage that the battery pack is at in the code through the voltage divider circuit over here. And then the current sensor that we're using is a Hall effect sensor. So the analog signal is coming as a voltage measurement, and then we're also converting that into current measurement. And based on the current measurement, whether we're charging or discharging, we'll turn on the LEDs, the appropriate LEDs. So in this case, discharging is red, whereas green is charging. And we'll also turn on the fan. So let's get into it. So over here, I'm going to start off by turning on the DC motor. So as you can see now, the current is reading negative, indicating discharging. There's a little bit of noise into the measurement. That's kind of expected. I should have bought better current sensors. But as I'm increasing the speed of the motor, the current is also, discharge current is increasing. And now I'm going to turn this off, and I turn on this DC power supply, which as a result is going to start charging up the battery. So as you can see, we have charging current and the voltage is increasing. However, the current sensor I'm using again is not the best, but just for demonstrating the idea, it should have increased enough where we could turn on the red LED. So if we actually increase the current here, it could, because they're not very accurate at low currents. So let's see. So now we're charging almost at 1 amp. It's not measuring correctly. Yeah, unfortunately, this current sensor is not the best. So, okay, now it's picking up. So it's reading higher current than it's supposed to, but I mean, just for demonstrational purposes, you can see the voltage increasing and also the current. So thank you so much for tuning in, and I hope you have a great rest of your day.